C# is one of the most popular programming languages in use and continues to make programming easier and more fun with each new version. In this course, we'll take a close look at defining and using types and fundamental control flow constructs with C#. I'm Matt Milner, and I've been programming with C# for 20 years. I continue using C# because I love how the language has evolved and the improvements I've seen to make programming easier. So please join me as we explore the essentials of C# types and control flow. Let's talk about what you need to know to get started with C# essential training. You should have some basic programming knowledge already, so either familiarity with another programming language or just general basic programming knowledge. Ideally, you'll have the C# basics covered, and a great way to do that is by watching the Learning C# course here on LinkedIn Learning. I'm going to assume that you have that basic level of understanding as we begin this course. All of the examples that I'll be showing use Visual Studio 2022 Community Edition with .NET 6 and C# 10 running on Windows. I'll point out features that are new in these versions in case you're using a previous version. It is possible to use Visual Studio 2022 for Mac. It's in preview at the time of the recording, or Visual Studio Code on Windows or Mac. But the experience won't be exactly the same, so you should be very comfortable with those tools if you choose to use them instead of Visual Studio 2022 for Windows. You can download exercise files for this course to follow along. Once you download and unzip the archive, you'll find a layout similar to this, where you have a folder for each chapter. And if we go into a particular chapter, each of the movies will have its own folder here. And within, you'll find a begin and end folder. Each of these has a LinkedIn.essentials folder with the solution inside. The begin directory will have the state of the solution as we start the video, and the end directory will have the corresponding state of the solution once the video is complete. Feel free to start with the begin and follow along, and you have the end there to compare when you're done. When learning a new programming language, I know I understand it better when I also learn the context in which it executes. For C#, that means understanding that code written in C# compiles to MSIL, or Microsoft Intermediate Language. C# is one of several .NET languages that all compile to MSIL. F# is a functional programming language, and Visual Basic .NET are two other languages supported by Microsoft with their own compilers that each know how to take those source files in the particular programming language and compile it to Microsoft Intermediate Language. One of the benefits of this is that the C# language can evolve independent of the runtime. So back with the .NET Runtime 4, .NET Framework 4 from years ago, we had a variety of different versions of C# that all were able to compile down to MSIL that could run on that one common runtime. And that gives the language flexibility to grow and change independent of the runtime. These days, for example, with .NET 6, released in the fall of 2021, you'll see that C# tends to release with .NET with new versions of the compiler. As an example, if we look at this simple Hello World application written in C#, we can compile it into an executable. So on the bottom pane or window, I've got a person class, and in the top, a simple Hello World where I create that person and write a message out. We can open that in a tool called ILDASM or the IL disassembler that allows us to see from a compiled .NET executable or library what the intermediate language is. So I can browse into LinkedIn Essentials here to my person class, and we can see all those properties, things like first name, age, last name, have get methods and set methods. So if I go to the get last name, for example, I can now see what the MSIL looks like. And in this case, we can see that line that starts with IL and 4 zeros, it's loading an argument. And then next, it's going to load a field. And for that, we've got the person last name K __ backing field. That's the auto-implemented field for our property definition, because our property simply identified a get and set, didn't put any particular code or expressions there, so that was created for us automatically. Likewise, if we go to the set last name, we can see that we have a method on the first line there called set last name, takes in a string of value. And then as you go down, you can see on IL0002 there that it sets a field. So now it's setting that backing field with the value that was passed in. Likewise, we can go down to the program, find our static void main. Now we can see all of those string literals like Matt and Milner, where we've got a load string command, and the actual message, the hello from, with our format there. And then that last one, we've got a call to our system console write line with the string. So all of that C# that we wrote all compiled down to this MSIL that can now get executed. Once C# or other .NET languages have been compiled to MSIL, they need to be executed. The .NET runtime is responsible for executing that intermediate language or those .NET executables. The runtime itself can be installed on a server or workstation separate from the SDK. So you don't need to have a developer set up. You can simply install the runtime, and then your application, compiled to MSIL, can run on that platform. There have been a variety of versions of the .NET runtime over the years. The most recent versions, which started with .NET Core, are cross-platform, so they can run on Windows or Linux or Mac OS. That means with C#, you can write your applications and you can target a variety of platforms, not just desktop or Windows, but also mobile platforms. Another feature of the more recent .NET versions is that the runtime can be deployed with your application, eliminating the need for a separate installation of the runtime. This is especially useful when deploying multiple applications to the same server where you might have different runtimes targeted by your application. So you can see here an application, separate runtime on Windows. You can also bundle that runtime in with your application to run on Linux or Windows or another platform, simplifying deployment and simplifying the management of those dependencies. When writing applications in C# or really any language, there are common pieces of functionality that are often provided in a software development kit or SDK. And because C# is one of several .NET languages, that common functionality is provided to all of them in the base class library, or BCL. The BCL contains types for the most basic of functions, such as string manipulation, mathematical functions, and working with dates, but it also contains more complex functionality around working with files, network streams, or data access. Application developers will typically build their own reusable libraries on top of the BCL and use these libraries in their applications as well. So you'll see a combination of direct calls from the application down to base class library types, as well as leveraging custom libraries that allow for reuse and definition of common business objects, for example. The base class library used to be the primary library used by all applications, and little else was needed or even available. These days, open source libraries, including those built by Microsoft, are available to use along with the base class library to build applications. So it's very common. In fact, many of the project templates from Microsoft will create an application, and you will start with the base class library as well as these third-party libraries added into your application to provide that functionality. And next, I want to talk about where you get all of those third-party libraries. While the BCL provides a lot of functionality through the various types it contains, there are more specialized areas of development that it doesn't address. Since .NET code is easily shared in the form of assemblies, or DLLs, many developers have created open source libraries to provide that additional functionality. You can plug these into your application, just like your own libraries, and leverage the logic or the rules or the functionality they provide. Once a library is created, you need a way to distribute it to others. This could be as simple as providing the assembly as a download on your website. This decentralized approach, though, is neither efficient nor secure, and it doesn't address many of the issues that crop up when creating libraries. For example, a library can be built to target different versions of .NET. So how do you properly distribute the various versions and make it simple for developers to know which to use and how to install it? How do you provide some assurance that the library is from a trusted developer and does what it says it will? That's where NuGet.org and the NuGet Package Manager come into the picture. NuGet.org is a repository for libraries that provides infrastructure, versioning, library, and developer information. A library is packaged with metadata and published to NuGet, where other developers can download and install it. The NuGet Package Manager is a tool used by developers both to create these packages and to install them in a project. Visual Studio natively supports NuGet for both creating and consuming these packages. I won't cover how to build NuGet packages in this course. That's something you can find in other courses here on LinkedIn Learning. Most developers tend to be on the consuming side of packages, installing them into their projects for use. When you use the NuGet Package Manager and install a library, it's automatically installed into your project and ready for you to use. In addition, you can easily update packages to a new version or uninstall them if you decide not to use them. One of the benefits of using NuGet over simpler methods of distribution is that a package can be much more than a DLL. Here you can see a NuGet package expanded to the file system. There's several files and folders here. If we open this up, this metadata file with Notepad, you can see it's very simple. It lists a version, a source, and importantly, the content hash, so that we could validate that what we downloaded matched what was published on the server. And if we go into the lib folder, you'll see we have a number of different folders based on the targeted framework, all the way back to .NET 2, 3, 5, and 4. This library, newtonsoft.json, also known as json.net, has been around for a long time. If we go into .NET Standard 2.0, there's the DLL and some XML documentation. So you can see this can get very complicated if we're trying to manage this on our own, on individual servers. Having a central place to go and download these packages, have this functionality to manage different target frameworks and the security and the versions is extremely helpful. The NuGet package models become mature and popular enough that Microsoft now ships many of their libraries through this platform. Everything from data access libraries to the libraries that make up the ASP.NET Web Programming Framework are now packaged and distributed using NuGet. This enables faster, more focused updates to the libraries rather than big bang approaches of an entire new framework every year or two. Individual libraries can also be updated independent of the other libraries. You can see here on their profile page on NuGet.org, they have over 6,000 packages, and that's 113 billion total downloads of all those packages. We're going to be focused on writing C# in this course, but I first want to touch on using the compiler to get your code to a runnable state. We'll start here with this C# class file. I've got the person class identified in this person.cs file, and I've also got a command prompt open. So I'm in that same folder. If I do a dir, you can see there's my person.cs in there. And I'm going to use the C# compiler, so CSC. I'll just pass that person.cs in. I'll tell it I want the output file to be called personlibrary.dll. And then I want to tell it the target. And so the target is library. And I'm telling the compiler, build this into a library or a DLL as opposed to an executable that could run. Compiler runs against that file on our parameters. We get an output. So if we look there, we've got our personlibrary.dll down near the bottom. If I go back into that ILDASM, again, we can pop that open. You'll see there's our library. We've got our person class just like we did before with our properties, fields, all defined for us, that same MSIL that we saw before. We'll clear that again. Remember, we also have this program.cs, our hello world that we did before, that uses that person. So now we've got two source files, and we've got a program that we want to run, or an executable. So we'll go back here, we'll pass in person.cs and program.cs. Now the out, I'll say hello.exe. And for the target, I can say win.exe or just exe. And here you can see we've got a small problem. Now we are getting a compiler error. It's telling us the name console doesn't exist in the current context. So there's clearly something a little different between what we're doing here and what we did previously with Visual Studio. Let's just go back here. And I'll come and put a system.console write line. We'll save that. We'll come run that compiler again. Now the compiler's happy. We should have output, which means we should be able to run hello.exe. And you can see we got our output, hello from Matt Milner, me to you. Now the compiler has a lot of advanced options for building your source files. But those are just the basics. And that's really all I want to show you right now, because Visual Studio that we'll be using to write our code, or other integrated development environments, are going to run the compiler for you in the background. There's properties you can set on your project to help control that if you need to. But now that you know the compiler runs behind the scenes, you've got that understanding if something goes wrong, where the source might be.